Okay guys, for the last half of Unit 7, we're going to be covering volume. You've done volume before. About the only new thing you might see is that you might have a base that's one of those regular polygons like the equilateral triangle or your pentagon, hexagon, octagon, things of that nature. So our formulas haven't changed. Our volume is still the area of the base, which is represented by the big B, and our H is the height between the bases. Couple of different formulas we can use for that big B. We have our triangle, rectangle, square, circle, and then also don't forget that you have that apothem times perimeter over 2 for a regular polygon. So the first couple of things that I like to do is to find the big B first. This is a right isosceles triangular prism. So our base is going to be a right isosceles triangle, 6 and 6 here. So my big B will be 1/2 base times height, which will be 1/2 of 6 times 6, which is 36. So our big B is 18 meters squared. And then for our volume, we're going to do area of the base times the height between the bases. In this case, our 9 is the height between the bases. So I'm going to have 18 times 9, which gives me a value of 162 meters cubed. The same applies to an oblique prism. It's still volume equals area of the base times the height between the bases. In this case, it's giving us this 3 as our height, so let's use that. And then it looks like we have a 3 by 3 square as our base. So our big B will be 3 times 3, which is 9. And the height between the bases is also 3. So our volume will be 27 inches cubed. We are given 2 of our values and we're asking to solve for the third. You can back up a box to length times width times height if you want to. You could also leave it as area of the base, which would be that length times width, and then put the height in there. Either way you look at it, we're going to have 7 times 5 times x is equal to our volume of 105. So 105 is equal to 35x. And if I do 105 divided by 35, it is 3. So it is 3 meters. Make sure that as you're working on these, I know you're answering them on the computer, but units are key, especially whenever you get into those upper levels. Make sure that if it needs a unit, that there's one there. So find the volume of a cylinder. We're going to do the same thing. Volume is area of the base times the height between the bases, and in this case, our base is a circle. So we're going to use pi r squared. And our radius is half of that diameter, so it's 9. So pi times 81. And then if I have 81 pi times a height of 20, then that gives me 1620 pi meters cubed. And then if you need to, you can go ahead and multiply those two together, but I'm just going to go ahead and leave them in exact form. Same thing here. We're going to use the height here, the perpendicular height from the two bases. And let's do our big B first. It's going to be pi r squared. So it's going to be pi times 4 squared, so 16 pi. And then we have a triangle here. If I back these down, this is 3 times 3 and 5 times 3. So this is our 3, 4, 5 right triangle. You can also use Pythagorean theorem, but if you can recognize those Pythagorean triples, that will help out. So our height is 12. So if our volume is area of the base times the height between the bases, that's going to be 16 pi times 12. And if we leave the pi out of it, 16 times 12 gives me 192, and then bring the pi back in, meters cubed. The volume of a cylinder with a diameter of 10 is 1,000 centimeters cubed. Determine its height to the nearest centimeter. So pi is going to be built in here, which means that we're going to have to take it back out. If our volume is area of the base times the height between the bases, I'm going to go ahead and expand this out. So the area of my base is pi r squared, and then times the height gives me my volume, and I'm going to plug in what I know. So if my diameter is 10, that means my radius is 5 centimeters. My volume, it tells me, is 1,000 centimeters. So pi times r squared, which would be 25, times the height. Now, when we divide by 25 pi, be careful how you plug this into the calculator. You're going to have to put all of this in parentheses underneath. So 1,000 divided by parentheses 25 pi, and in parentheses gives us, let's see, rounded to the nearest centimeter, it's 12.7, so 13 centimeters. Be very careful with this set over here. It's not going to let me use my highlighter. Be very careful with this operation over here. If you just plug in 1,000 divided by 25 pi, what it will do is, in your calculator, it will process it as 1,000 divided by 25 times pi. And we also want to divide by the pi, so just make sure that you put both of those in parentheses. All right, our last example here is a swimming pool. It tells us our max depth is 4 feet. And what is the maximum volume for this pool? It also tells us that we have a diameter of 30, so our radius is 15. So if we plug that into our area of the base times the height between the bases, I'm going to have pi r squared h. So pi times 15 squared is 225 times a height of 4. So times 4 gives me a volume of 900 pi cubic feet. And if 1 cubic foot is approximately 7.48 gallons, what is the maximum number of gallons this pool can hold to the nearest gallon? So I'm going to take my 900 pi times 7.48, and I end up with 21,149 gallons.